Hey everyone, ready to explore some groundbreaking AI? Today we're doing a deep dive into DeepSeek V3 R1, a system that's seriously shaking things up in terms of efficiency and speed. Might even change the way we think about AI development entirely.
Absolutely. It's fascinating how they're achieving this level of performance. They've designed their system to handle massive amounts of data quickly and with super fast response times.
Yeah, and they're keeping costs way down in the process, right? I was reading that they claim a profit margin over 500%, even with less expensive hardware than some of the big names out there.
Exactly. Their secret weapon is expert parallelism. They basically break down their AI model into 256 smaller, specialized units. You can think of them as experts, each focused on a specific task. And these experts are spread out across hundreds of GPUs for parallel processing.
So instead of one giant AI brain, it's more like a team of specialists working together. I like that analogy, but wouldn't that create a ton of communication overhead between those GPUs? Keeping everything coordinated must be a huge challenge.
You're right. Coordinating all those experts across multiple GPUs is a major hurdle. DeepSeek tackles this with some pretty clever solutions. One of them is double batch overlapping.
Okay, I'm intrigued by that one. Sounds complicated.
Well, it's actually a pretty ingenious concept. Imagine two assembly lines working side by side with double batch overlapping. DeepSeek intertwines the computation and communication for two separate batches of data. So while one batch is being processed, the system's already sending and receiving data for the next one.
So there's essentially masking the communication delay by overlapping it with processing time. That's pretty smart. But what about making sure all those GPUs are actually being used efficiently? I imagine just one overworked GPU could slow down the entire system.
That's where DeepSeek's load balancing mechanisms come in. They've got three main types: the pre-fill load balancer, the decode load balancer, and the expert parallel load balancer.
Okay, so these load balancers are kind of like air traffic controllers, making sure everything runs smoothly and no single GPU gets overloaded.
Exactly. Each load balancer focuses on a different aspect of the system. For example, the pre-fill load balancer ensures an even distribution of workload. For a critical operation called core attention, it involves processing relationships between different parts of the input data, and it balances the number of tokens each GPU sends. Tokens are the basic units of data the system works with. It prevents any one GPU from getting bogged down.
Okay, got it. So that's the pre-fill load balancer. What about the decode load balancer? What does that one focus on?
The decode load balancer manages the usage of something called KB cache. You can think of it like a high-speed memory bank, where the system stores frequently accessed information. The decode load balancer makes sure this KV cache is used evenly across all GPUs, so no single GPU becomes a bottleneck.
So it's all about maintaining smooth and balanced access to this important information store. And it also balances the number of requests coming in, right?
Exactly. Now the third one, the expert parallel load balancer, handles the unique challenges posed by the experts themselves.
I thought all the experts were equal partners in this AI team. What kind of challenges are we talking about?
Well, some experts might be assigned more computationally intensive tasks than others, depending on their area of specialization. The expert parallel load balancer keeps track of each expert's workload and dynamically adjusts their distribution across the GPUs so that no single expert or the GPU running it gets overloaded.
So DeepSeek has basically built this system where all these specialized experts work together seamlessly. Thanks to some pretty clever management techniques. That's impressive.
It is, and the real-world performance data is pretty remarkable. At peak usage, they were running 278 nodes, each with 8 H800 GPUs.
Wow, that's a lot of processing power. What kind of numbers are we talking about in terms of actual data processed?
In just one day, they managed to process a staggering 608 billion input tokens. To put that in perspective, imagine processing the entire Library of Congress multiple times over.
And they're doing all of this while maintaining a really impressive output rate. I read somewhere that they're hitting something like 20 tokens per second.
That's right. They're consistently achieving an output rate of 20 to 22 tokens per second.
This is all incredibly fascinating, but I have to admit I'm still a bit unclear on some of the technical details. For example, what exactly are these tokens you keep mentioning, and how do they relate to the actual data being processed?
That's a great question, and it's key to understanding how the system works. Let's break down those technical details and explore how DeepSeek achieves this incredible level of efficiency right after a quick pause.
Yeah, you're right. Understanding tokens is crucial here. Basically, they're the building blocks of language, the fundamental units that DeepSeek's AI model works with. Think of it like breaking down a sentence into individual words or even parts of words. This allows the model to handle language much more efficiently.
So when you say they processed 608 billion tokens, that means they analyzed 608 billion individual pieces of language. Exactly, and another key aspect is their use of specific data formats, FP8 and BF16. These are optimized ways of representing numbers for AI processing. Using these formats allows for faster calculations and requires less storage space, so it contributes to the system's overall efficiency.
Got it. So they're really squeezing every bit of performance out of the hardware, carefully choosing data formats and processing methods that align perfectly with their goals.
Exactly. DeepSeek has taken this holistic approach to optimization, considering every aspect of the system, from the model's architecture right down to how the data is represented.
Let's go back to the cost efficiency for a second. You mentioned that DeepSeek claims a profit margin over 500%. How is that even possible in such a competitive field?
It all comes down to their innovative system design. By using expert parallelism, they can leverage less expensive hardware. Remember, they're spreading the workload across hundreds of relatively affordable GPUs. Instead of relying on a smaller number of those super expensive top-of-the-line processors.
That makes sense, distributing the work to get more bang for their buck. But isn't this kind of going against the grain in AI development? It seems like everyone's focused on building bigger and bigger models, which often require that massive, expensive infrastructure.
You've hit on a key point there. DeepSeek is definitely challenging the conventional wisdom in AI. Their success with a more budget-friendly approach raises questions about whether those huge expenditures on high-end hardware are really necessary.
It's like they're proving you don't need the biggest, flashiest tools to get groundbreaking results. That's pretty inspiring, especially for smaller companies or research teams who might not have access to those vast resources.
Absolutely. DeepSeek's success could have a ripple effect throughout the entire AI industry, democratizing access to advanced AI technologies. And they're actively contributing to that by open sourcing several key modules of their system.
Oh, right. I read about that.
Right.
Why would they choose to share their technology with everyone? Isn't that giving away their competitive advantage?
It's a strategic move for sure. By open sourcing these modules, they're fostering a collaborative ecosystem around their technology, allowing more developers to experiment with it and build on their work. Ultimately, it benefits them as well, leading to a wider user base and more diverse applications.
So it's a win-win situation. They drive innovation and potentially set the industry standard, while others get to use these powerful AI tools. But let's not forget, they took a big risk with this approach. Developing a system based on expert parallelism must have come with some major engineering challenges. There's no guarantee it would pay off.
Absolutely. They had to build their system from the ground up, creating new architectures and processes specifically designed for their unique model structure. It was a gamble, but it looks like it's paid off spectacularly.
I'm curious, what impact do you think this will have on the competition? Some of the big players like OpenAI have invested heavily in that expensive hardware and infrastructure. Could DeepSeek's success disrupt that model?
It's definitely a possibility. DeepSeek's cost-effective approach could put pressure on those companies, the ones who've relied on massive spending to achieve their results. It forces them to reevaluate their strategies and consider if there are more efficient ways to achieve their goals.
This is all incredibly fascinating. DeepSeek is not only pushing the boundaries of AI technology, but also challenging the way the whole industry thinks about costs and efficiency. It's a story that's still unfolding, for sure, and it'll be interesting to see how it all plays out. But before we get too carried away speculating about the future, let's take a step back and look at how all of these pieces fit together in DeepSeek's actual system. We've talked about expert parallelism and load balancing, but how do they function in the real world?
That's a great point. Let's delve into the practicalities of how these components work together to create such a remarkably efficient and powerful AI system.